Hello everyone! In this virtual lab, we're going to calculate the strain for two steel specimens having different cross-sectional areas. Let's click Specimen and select the short thin steel specimen and the short thick steel specimen. And let's apply a load of 40 newtons. What are the values of strain for each specimen? Great! Let's check your answer. Sample 1, which is the thin specimen, is represented on the graph with a pink curve at a load of 40 newtons. Its extension is 10 millimeters, and it has an original length of 40 millimeters. So the strain is equals to 10 millimeters divided by 40 millimeters, which is equals to 0.25. However, the thicker specimen is sample 2, and it's represented on the graph by a green curve at a 40 newtons load. It has an extension of 40 millimeters, so the strain is equals to the extension divided by the original length, which is equals to 5 millimeters divided by 40 millimeters, equals to 0.125. As you notice, the strain for the thicker specimen is less, and this is because it does not stretch so much. Now let's increase the load until the thin steel specimen breaks. Calculate the strain when the short thin steel specimen snaps. Recall, sample 1 is represented by a pink curve. So when the specimen snaps, it has an extension of 18 millimeters. So the strain is equals to 18 millimeters divided by 40 millimeters, which is the original length. So the answer is 0.45. Great job!